James, Education and Outreach Coordinator with Eagle River Watershed Council. Over the past few weeks, we've learned about many different pieces about our watershed. We've learned what is a watershed, what makes a watershed healthy, how to tell if a watershed is healthy, how we use water within our watershed. Today, we're going to take that the next step further and figure out where the water goes once it leaves our watershed. Today, we're going to talk about the plumbing of the Colorado River. Before we take our trip down the Colorado River, let's back up a little bit and see if we remember what a watershed is. A watershed is an area of land that drains into a river, a lake, another basin of some sorts, and reminder that we're in the Eagle River Watershed. Today we're going to talk about the Colorado River Watershed at large, which covers 7 states and 2 Mexican territories and gets its headwater starts in Wyoming at Grand Teton National Park flowing down the Green River, and in Colorado at the Rocky Mountain National Park and flows down the upper Colorado into the Colorado River, which happens to flow through our county. The Colorado River is split into 2 basins, the upper basin and the lower basin, and each get an allocation of water from the 1922 Colorado Compact. Each basin gets 7.5 million acre feet. For visualization, an acre is about 1 football field. So imagine 7.5 million football fields all covered in 1 foot of water. And that's how much each basin gets every year. Mexico entered a treaty in 1944 getting 1.5 million acre feet of water that's flowing through the Colorado River. Now, what uses the water? Water uses span many different things, as we learned in a couple weeks ago when we talked about our water footprint and how we use water. We use water in many forms, from food growth, agriculture, to energy production, urban population growth. The earth processes need river water, fish and wildlife need river water. There's a lot of different uses for water. Now, the problem we have is that there's only about 14 million acre feet of water flowing through the Colorado River. Let's back up a second. I'm pretty sure we just said that each basin gets 7.5 million acre feet, so that's 2 times 7.5, and Mexico gets 1.5 million acre feet. That adds up to 16.5 million acre feet, but there's only 14 million acre feet flowing through the river. Where does all of that water go? How do we all allocate it? How does it get used? That's what we're gonna find out today as we take a trip down the Colorado River, metaphorically speaking, and learn about the plumbing of the Colorado River. Welcome to the Colorado River Watershed. This is shrunken down for scale and marked so we know where we are within the watershed, but we're going to run through a little tour showing where the water goes as we move through each of the sections of stream. With me right here is our first precipitation bucket, which applies all of the water for the Colorado River. Scattered throughout are more buckets with our Colorado River, our Green River, where our water use goes, the confluence of the Green River and the upper Colorado River, and then below me is the Colorado River Delta bucket, so we can see how much water actually makes it to the Sea of Cortez. Starting our tour in the Green River Watershed at the headwaters, which is in the Grand Teton National Park. Before I start, for reference, each cup of water that I'm going to take from this bucket into this bucket is about 200,000 acre feet of water. The headwaters supply the Green River 4 1/3 cup of water, which then flow down to meet the rest of the stream, or be used. Next is our first water usage. So right here is Flaming Gorge Reservoir, which is downstream from the headwaters, and it uses about 1/2 cup of water just because of evaporation and seepage into the groundwater. This dam is used for hydroelectric power. So when we use the water, we're going to take it out of this basin because this is what water is in the basin currently, and that's available to be used. Put it into our evaporation and losses bucket. All right. Next, we have the Central Utah Project. This diverts water from the Green River and takes it mostly to Salt Lake City to be used for agriculture and irrigation and for domestic water supply for drinking water. Each of those get about 1/4 cup of losses or use from the Green River. Now we have 2 rivers that are tributaries to the Green, and one of them is the Duquesne River and the other one is the Price River, and both of those add about 1 cup of water to the Green River basin, which means we take them from the precipitation bucket, not from the river themselves. And that completes our Green River profile. So now we're gonna travel about 500 miles and jump back to Rocky Mountain National Park and start the Colorado River Basin. If only traveling from Grand Teton National Park to Rocky Mountain National Park took just that long. I'm over here in the headwaters of the Colorado River, which get their start at Rocky Mountain National Park. Just like Grand Teton National Park and the headwaters of the Green River, this also supplies 4 1/3 cups of water into the basin, which, as we said, about 200,000 acre-feet per cup of measure. Pretty quickly from the headwaters, water is diverted from the western slope, which is where we live and where water flows down through the Colorado River, to the Front Range through the Colorado Divide, which is into an entirely different watershed, flows down into the Mississippi River. This water is used for many reasons, from agriculture in eastern Colorado and Kansas and Oklahoma to drinking water from Fort Collins all the way to Colorado Springs. And that takes about 1 cup out of the basin right away, with 3/4 going to agriculture and 1 cup going to domestic use. This diversion is done through a pipe that gets its start in Grand Lake and goes to Mary's Lake outside of Estes Park. And the tunnel itself is about 9 feet and 9 inches in diameter, which is about 4 feet taller than I am. From there, the water then continues on, and we meet up with the Gunnison River, which adds about a cup of water to the Colorado River basin. The Gunnison meets the Colorado River in Grand Junction, which is about 2 hours west of where we are. Even further downstream is the Dolores River, which gets its start and drains the Four Corners region of Colorado, Utah, Mexico, and Arizona, and meets up with the Colorado River just over the Utah border. And that adds another cup of precipitation and runoff and drainage into the Colorado River basin. Now, next up on the tour is where the Colorado River and the Green River meet, and that is in Canyonlands National Park in Utah. And both rivers merge to become just the Colorado River that continues on for another over 1,000 miles of stream. We're going to pour the Colorado River and the Green River into this bowl, which represents the merging of the two in Canyonlands. So now that our Upper Colorado and the Green River have merged, we're running down the main stem of the Colorado River, which gets its start in Utah at Canyonlands National Park, as I said. And first, it gets an addition, and it gets 2 cups of water from the San Juan River, which drains New Mexico and Utah and meets the Colorado River just upstream of Lake Powell. So that gets 2 more cups of water from our precipitation bucket. All right. However, almost immediately, a bunch of water is used through Lake Powell in terms of evaporation and losses. Lake Powell is a huge dam behind Glen Canyon Dam in Arizona, and it loses about a cup of water, metaphorically, to evaporation and loss. To our loss bucket. Our next check-in point here on the Colorado River is Lee's Ferry. Now, Lee's Ferry is significant because it was a point in the river that was used in the 1922 and 1944 compacts that estimated flow for the Colorado River, which is how we allocated 16.5 million acre-feet in total. Downstream from there is the Little Colorado River, which starts in the White Mountains of Arizona and meets the Colorado River after passing through Navajo reservations. And it is a beautiful blue color, almost just like these strings from travertine and limestone that's been dissolved into the river. It's a really stunning visualization to watch this blue river flow into a kind of a murky brown Colorado River. So we get another cup of water added into the Colorado River. Next we have the Virgin River, which flows through Utah, Nevada, and Arizona, and it doesn't add a whole heck of a lot of water, but it does add about one third cup of water to the Colorado River in Arizona. Water. So much water. Perhaps you've noticed that all of the inputs to the river are a light blue color, and they're on this side of the river, whether it was the green Upper Colorado or the Colorado, and all of the outputs are in red, and they're on this side. We just finished our last input for a long while before we get down to here, but if you notice, there aren't any blues, and we're gonna get to that later. I'm gonna summarize all of these outputs, as we travel down the Colorado River, and then at the end, I'm gonna summarize how much water we've lost to agriculture, to domestic use, and to evaporation and losses from reservoirs. just summarized the All-American Canal, which was one of nine of the outputs that have traveled through the Colorado River. And now I'm going to summarize how much water was taken out of the Colorado River for evaporation losses, agricultural use, and domestic use. In total, we had about 2¼ cups of water that was lost to evaporation. We had 6¼ cup that was used for agriculture purposes, which is growing our food, raising cattle, anything like that. Not calculated is the loss due to spillage from the cup measuring cups. And then finally we have 2 cups of water that was used for domestic purposes, which is what we use inside of our homes and for also watering our grass. As you can see, that took out a whole bunch of water from the Colorado River, and we still have a little bit to go and a little bit more usage that happens. We do have 2 inputs over here, but they don't add a significant amount of water. Both of these, the Gila and the San Pedro River, are dammed and are used and drained, tapped into upstream, so not a lot of water makes it to the Colorado River. After a long journey, we've made it to Mexico, and as we just noticed, the Colorado River isn't carrying a whole lot of water right now. We've diverted a ton of it. It's been used for agriculture, for domestic use, and a lot of it has been lost to evaporation and to seepage into the groundwater through diversion structures and dams. But now we've reached Mexico, and we have the Morales Dam, the Canal Independencia, and the Colorado River Tijuana Aqueduct. All of those have water uses that total about 1.5 cups, with 1 cup going to agriculture and 1/2 cup going to domestic use. 1/2 cup going to domestic, 1 cup going to agriculture. There's also probably some evaporation losses, but not as quantifiable as the other uses here. So this, out of all of the water that was in the Colorado River, from the headwaters in the Colorado, where the Colorado River started, to where the Green River started, flowing down, this is all that we have left, and this is all that reaches the Sea of Cortez. This is a little bit more than we expected even, and oftentimes there's not water that reaches the Colorado, the Sea of Cortez and the Colorado River Delta. It hasn't gotten significant amount of water since the 1990s.